Hello, a very good afternoon. Today we are going to discuss about the Newton's laws of motion. So we are going to discuss about the Newton's laws of motion given by Sir Isaac Newton. Let us know that this Isaac Newton is an great English scientist and mathematician, and he has discovered the law of gravity also. So now we are going to discuss about the Newton laws of motion. The first law, the second law and the third law. So the first law is that the objects tend in rest unless and until they are acted upon the unbalanced force. Second law is equal for mass time acceleration, and third is you all know. The first law is that an object at rest tends to stay at rest and an object in motion tends to stay in motion unless and until and acted upon by an unbalanced force. This is the Newton's first law. Okay, now we should know what does that exactly mean. So basically an object will keep doing what it was doing unless acted on by an unbalanced force. If the object was sitting still, it will remain stationary. If it was moving at a constant velocity, it will keep on moving. It takes force to change the motion of an object. So what is meant by unbalanced force? So if the force on an object are equal and opposite, they are said to be balanced and the object experiences no change in the motion. If they are not equal and opposite, then the forces are unbalanced and the motion of the object changes. So here the book is kept on the table, the gravity is pulling down the book. Here it is an balanced force. Some examples from the real life. A soccer ball is sitting at rest. It takes an unbalanced force of a kick to change its motion. Two teams are playing tug of war. They are both exerting equal forces on the rope in opposite direction. This balanced force results in no change in motion. Now we are moving with the Newton's first law is also called as the law of inertia. So inertia means the tendency of an object to resist changes in its state of motion. So the first law states that all objects have inertia. The more mass of the object has, more inertia it has. The harder it is changed to its motion. Okay, so this is about the Newton's first law. And when this Newton's first law and so don't let this be you. Wear seat belts. Because of inertia, objects resist changes in their motion. When the car going 80 kilometers per hour is stopped by the brick wall, your body keeps on moving at 80 kilometers per hour. This is about the Newton's first law. Some more examples. A powerful locomotive begins to pull a long line of boxcars that were sitting at a rest. Since the boxcars are so massive, they will have a great deal of inertia. So once they are moving, it takes large force to stop. On your way to school, you are seeing a bug is flying into your windshield. Since the bug is so small, it will have a very little inertia and will exert a very small force on your car that we can't feel it. Okay, so if the objects are in motion, they tend to stay in motion. So why don't we general objects keep moving forever? Things don't keep moving forever because there are almost always an unbalanced force acting upon. A book sliding across a table slows down and stops because of the forces of friction. We call it as gravity. So, in an outer space away from the gravity, any other sources of friction, for example, a rocket ship is launched with a certain speed and the direction would keep going in the same direction and at the same speed forever. Okay, this is about the Newton's first law and some examples in our day-to-day life. Now we are moving to the Newton's second law. So Newton's second law states that the force equals mass times accelerations. F is equals to ma. Acceleration means a measurement of how quickly an object is changing its speed. So now we are going to see what does F is equals to ma mean. So force here is directly proportional to the mass and acceleration. For example, imagine a ball of a certain mass moving with a certain acceleration will have a certain force. So what does F is equals to ma say? F is equal to ma generally means that the force of an object comes from its mass and acceleration. If you double the mass, double the force. If you double the acceleration, you double the force. So doubling the mass and the acceleration quadruples the force. So here what if you decrease the mass by half, the object would have. So what does this F is equals to ma generally say? So it means that force of an object comes from its mass and acceleration. Something which is very massive, that means that have changing the speed very slowly, like a glacier can still have a great force. So likewise a bullet will have a very weak force even. Now we are moving with Newton's third law. You all know, we all are familiar. For every action there is an equal and opposite reaction. This is the Newton's third law and it is very easy to understand. So what does this mean? For every force acting on an object, there is an equal force acting in the opposite direction. Right now, gravity is pulling you down in your seat. But third law says that your seat is pushing up against you with equal force. That is why we call it as a balanced force acting upon. So think about it. What if you are standing on a skateboard or a slippery floor and push against a wall? You slide in the opposite direction because you pushed on the wall, but the wall pushed back to you with equal and opposite force. Similarly, when we are walking, the same is acting upon to the ground and our feet. So, Newton's laws of motions. We just review once. Newton's first law is that objects in motion tends to stay in motion and objects at rest tend to stay at rest unless a force is exerted. Newton's second law is F is equals to ma. Third law is every action has a equal and opposite reaction. So these are the vocabularies we are learning: inertia, acceleration, velocity and force. Force is a push or pull, velocity is the rate of change of position, acceleration is change in velocity and inertia is the tendency of the object when it is in state of motion. Bye bye.